In this episode, we're going to make web-based automation feel less like guesswork by understanding how RESTful design and basic request structure actually work when you're talking to an interface over the network. A lot of automation today is really just one system asking another system to do something, and the most common language they use is web requests. If you're new, it can be frustrating because you might send a request that looks reasonable and still get a confusing response, or you might succeed once and then fail later because you didn't understand why it worked. The calm way through that confusion is to learn the small set of rules that make requests predictable: the method you choose, the headers you send, the body you include, and the way you interpret responses. When those rules are followed, automation becomes repeatable because each call has clear meaning and the system can reliably decide what to do. When those rules are ignored, automation becomes brittle because the same action can behave differently depending on hidden defaults. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Representational state transfer, REST, is a style of building network interfaces where you treat pieces of information as resources and interact with those resources using a consistent set of operations. The reason this style is popular is that it makes interfaces easier to learn and easier to automate, because the same patterns repeat across many systems. Instead of inventing a brand new command for every action, a REST interface usually encourages you to use standard methods to create, read, change, or remove resources. That makes the automation problem feel more like composing sentences from a known vocabulary rather than inventing a new language each time. Beginners sometimes assume REST is a specific technology or product, but it's really a set of design habits that lead to predictable interactions. Those habits include identifying resources with stable paths, using methods to express intent, and relying on standard status responses to communicate outcomes. When the interface follows these habits, you can reason about what will happen before you send the request, which is the foundation of safe operations. Create, read, update, delete, CRUD, is the simplest way to describe the 4 basic lifecycle actions you take on resources. If you think about a resource as a record, like a user profile, a device entry, or a policy object, then CRUD is how you create it, look at it, change it, and remove it. This matters operationally because most automation tasks boil down to those 4 actions, even when the real-world meaning sounds more complicated. Adding a user is create, checking a user is read, changing a role is update, and deprovisioning is delete. The challenge for beginners is that different systems express these actions with different rules about data shape and permission, so your job is to keep the conceptual model clear even when the details differ. When you keep the model clear, you're less likely to perform the wrong action, like trying to update something that doesn't exist or deleting something you intended to disable. Clear intent is a safety control. Methods are the verbs that communicate your intent, and the operational outcome depends on choosing the right verb for the action you want. In a REST-style interface, you generally use one method for reading, another for creating, and another for updating or deleting. The reason method choice matters is that servers often treat methods differently in terms of which operations are allowed, which permissions are required, and what side effects are triggered. Beginners sometimes send the correct data but the wrong method and then wonder why they get an error, or they accidentally perform an action that changes state when they thought they were only reading. The safest habit is to decide what kind of operation you are doing before you write the request, and then choose the method that matches that intention. When your method matches your intention, troubleshooting becomes simpler because errors are more meaningful and successful calls are more predictable. This is also how you avoid silent mistakes, which are worse than loud failures in automation. Headers are where many beginners get tripped up because headers feel like optional metadata until you realize they are often the rules of engagement for the request. A header can tell the server what kind of data you are sending, what kind of data you are willing to receive back, and what identity or token you are using to prove you have access. If you send a body without telling the server what format it is, the server may interpret it incorrectly or refuse it. If you don't specify what responses you can handle, you might get a format that your automation can't parse reliably. If you omit required authentication information, you might get a response that looks like the server is broken when it is really just denying access. Operationally, headers are what make interactions explicit, which reduces ambiguity and reduces surprises across environments. When you treat headers as part of the contract, you stop relying on defaults that may differ between tools, versions, or platforms. That is how automation stays portable and predictable. Hypertext Transfer Protocol, HTTP, is the common framework that defines how these requests and responses are structured, including methods, headers, and status outcomes. The most important beginner insight is that HTTP is designed to be stateless in the sense that each request should carry enough information for the server to understand it on its own. That doesn't mean servers don't remember things, because servers can maintain sessions and store data, but it does mean you shouldn't assume the server remembers what you meant unless you send it explicitly. This is one reason automation can fail in confusing ways when you send incomplete requests, because a human might rely on context while the server relies on what is actually in the message. It also explains why headers and tokens matter, because your identity and permissions must be represented in each request in an expected way. When you build automation on a stateless message model, you gain reliability because each call is self-contained, and troubleshooting becomes a matter of inspecting a single request and response rather than guessing at hidden state. Reading data is often the least risky operation, but it still requires precision because reads can fail due to permissions, missing resources, or wrong paths. A read operation should not change anything, and that property is valuable because it allows you to probe the system safely to confirm what exists before you attempt to change. This is one of the most important safety patterns in automation. Read first, then decide whether you need to create, update, or delete. Beginners sometimes skip this because they want to go straight to make it so, but skipping reads increases the chance of duplicates, conflicts, and accidental replacements. A clean read also teaches you the shape of the data the server uses, which helps you craft correct create and update requests. Operationally, a good read response becomes your evidence of current state, and evidence is what keeps you out of guessing mode. When reads are consistent and well-parsed, you can build idempotent behavior by using reads as checks and using changes only when the system is not already in the desired condition. Creating resources sounds straightforward, but it often exposes the most practical details about correctness, because creation requests must provide required fields and must respect uniqueness rules. Servers often enforce constraints like required names, allowed values, and relationships to other resources, and those constraints are part of what keeps the system coherent. Beginners sometimes interpret creation errors as arbitrary, but they are usually telling you that the request did not satisfy the resources contract. Headers matter here because creation typically includes a body, and the server must know how to interpret that body. Identity also matters because creation is often restricted to specific roles, so you must expect authorization checks. Operationally, a safe create operation is one that is repeatable without producing duplicates, which means your automation should either detect whether the resource already exists or use stable identifiers that make creation idempotent. The goal is that rerunning the same automation doesn't create a second copy of a resource just because the first run succeeded but the confirmation step failed. Predictable create behavior is a core requirement for reliable systems. Updating resources is where method choice and data shape become especially important because there are different philosophies about what an update means. Sometimes an update request represents a full replacement of a resource's representation, and sometimes it represents a partial change to only a few fields. Beginners can get into trouble by assuming one style while the server expects the other, because a full update can accidentally wipe fields you didn't include, while a partial update can fail if the server requires a complete representation. The safe operational approach is to treat updates as controlled changes. Understand whether you are sending the full representation or a partial one, and ensure the server can interpret your intent based on the method and the headers. Another common update pitfall is concurrency, where a resource changes between the time you read it and the time you update it, which can cause conflicts or accidental overwrites. When systems support it, versioning signals can help prevent overwriting newer changes, but the concept you need as a beginner is simpler. Updates should be based on fresh knowledge of current state, and they should be as small as possible while still expressing the intended change clearly. That keeps automation safe under real-world churn. Deleting resources is often the highest risk action because it can be irreversible or can trigger downstream effects that are hard to predict. Even when a delete is logical, like removing a stale record, you must consider what depends on that resource and whether the system uses soft deletion or hard deletion. A soft delete might mark the resource as inactive while keeping history, while a hard delete might remove it completely, which can break references and cause failures in other components. Beginners sometimes treat delete as cleanup, but in operations, deletion is a change that should be deliberate and evidence-based. A safe deletion pattern starts with reading the resource, confirming it is the correct one, confirming dependencies, and then deleting in a way that the system expects. Headers and method correctness matter because delete operations often require strong authorization and may require specific conditions to be met. Another important safety idea is that repeating a delete should not cause chaos, which means your automation should handle already deleted outcomes gracefully rather than treating them as catastrophic errors. That makes reruns reparable and reduces the pressure to do manual intervention. Correct headers are not just about making the server happy. They are about reducing ambiguity so your automation can reliably parse and respond to outcomes. One of the most practical header concepts is negotiating what format you send and what format you expect back, because automation depends on parsing responses consistently. If the format changes unexpectedly, your automation can misinterpret fields or fail to extract the values it needs, which can lead to incorrect decisions later in the workflow. Authorization headers, where you present a token or credential, also affect reliability because access failures can look like missing resources if you don't interpret responses carefully. Beginners sometimes chase the wrong problem when a request fails, thinking the resource doesn't exist when the real issue is that they aren't allowed to see it. Treating headers as part of your request contract reduces these misunderstandings because you are explicit about identity and data format. Operationally, explicit requests lead to explicit errors, and explicit errors are far easier to troubleshoot than ambiguous failures. This is why well-designed automation treats headers as required inputs, not as optional decoration. Response interpretation is the other half of the contract, because automation isn't complete until you can decide whether the request succeeded, failed, or needs a different action. Servers communicate outcomes through status codes and response bodies, and your automation must treat those as structured signals rather than as vague messages. A success might include the created resource, a location of the new resource, or confirmation of an update, while a failure might include an explanation of what constraint was violated or what permission was missing. Beginners often look only at the body and ignore status, or look only at status and ignore body, but reliable automation uses both because each provides different evidence. Another practical point is that some failures are actually normal control signals, such as an indication that a resource was not found, which might be expected during a creative missing workflow. When you interpret responses thoughtfully, you can build safe branching behavior without guessing, such as deciding to create only when a read indicates absence. This is how you turn CRUD calls into idempotent workflows rather than one-shot scripts that panic when reality doesn't match assumptions. Security and reliability meet directly in how you handle authentication, authorization, and sensitive data in requests. When you automate against interfaces, you are often sending tokens or keys that grant access, and you must treat those as critical assets because they represent power. Even if your automation is correct, poor credential handling can turn the automation channel into an attacker's shortcut into your systems. At the same time, overly broad permissions can make automation dangerous because a small bug can cause large damage quickly. The operational goal is to use least privilege identities for automation, meaning the identity has only the permissions required for the specific CRUD operations it must perform. That also improves reliability because permissions errors become clear indicators of misconfiguration rather than unpredictable behavior, and it reduces the blast radius if credentials are exposed. Another reliability point is that error handling should not leak sensitive information into logs, because logs are widely read during incidents. When you balance security and troubleshooting needs, You make the system safer without making it impossible to operate under pressure. The most automation-friendly mindset you can develop is to treat each call as a small, testable contract. The method expresses intent, the headers define rules and identity, the body carries data when needed, and the response provides structured evidence. When that contract is followed, you can combine calls into workflows that are safe to rerun and safe to repair after partial failure. Reads become your checks, creates become your controlled introductions of new resources, updates become your precise drift corrections, and deletes become your deliberate retirement actions. That workflow approach is what turns calling an interface into operating a system. Because you are no longer firing requests blindly, you are steering the environment toward a desired condition with evidence at every step. Beginners often want a single magic request that does everything, but real reliability comes from small, clear interactions chained together with state awareness. When each step is clear, the whole workflow becomes easier to audit, easier to troubleshoot, and less likely to produce side effects you didn't intend. That is the heart of practical automation over web interfaces. To close, performing REST-style CRUD operations reliably is not about memorizing a dozen special cases, but about building disciplined habits around intent, structure, and evidence. You choose methods that match what you mean to do so the server can apply the correct behavior and permissions. You send headers that make your identity and data formats explicit so both sides interpret the request the same way every time. You use reads to confirm state before changes, and you interpret responses with care so your automation reacts to real outcomes rather than to assumptions. You design create, update, and delete actions to be safe under reruns by avoiding duplicates, avoiding accidental replacement, and handling already done situations calmly. When you apply these principles, web-based automation stops feeling fragile and starts feeling like a reliable operational tool because each interaction has clear meaning and predictable results. That predictability is what makes large-scale automation possible without turning your environment into a maze of hidden side effects.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.